So here's the learning targets, obviously. Now there's 2 learning targets there, but we really should have just made it 1. Because if you can break down or decompose a polygon into smaller figures to find the area, that's exactly the same learning target as finding the area of a composite figure. Because you are going to break down a composite figure to find or you're going to decompose it to find the area. So those are the same learning target. I don't even know why we have them separate. They shouldn't be. Let's look at the first one here. Now, first thing I want to talk about is what shape is that? What is that shape? Yeah?
Pentagon.
It is a pentagon, a 5-sided pentagon. Okay, I always get hexagons and pentagons confused myself. I can never remember which one is which. Okay, so I always get hexagons and pentagons confused. Always did. Don't know why, but I think I finally got them figured out, I hope. Don't ask me on the fly, because I'll get them wrong. So sometimes I don't know why, but I remember them as, the Pentagon building in Washington, D.C. That's how I remember it now, because I know that's the shape of the building. So that's how I remember it. As silly as that seems. Okay, so do you think there is an area formula for a pentagon?
Yeah.
Sure, guarantee it's on the internet somewhere. I have no idea what it is, but I'm sure it's there. Okay? No idea, I really don't care. Because, we've got to talk about one more thing real quick. We got to talk about this word regular. What a regular polygon is. What is a regular polygon? Yes?
Shape that's not, like, all the sides are the same length.
Yep, all the sides are the same length. So basically that's the same as that, which is that's the same. And then also the piece from the vertices into the center, those are all the same length also. So basically it creates isosceles triangles, which is 2 sides the same. Okay? Like I said, I could teach you all the formula, or I could look it up and teach you the formula for a pentagon, but I just don't understand the point. Because then you'd have to learn another one for a hexagon. You'd have to learn another formula for an octagon, another formula for a decagon. I'd rather just know how to do it. You guys agree with that?
Yeah.
So what I'm going to do is I'm going to highlight just one of these little triangles here. Okay, obviously if there are 5 sides, then it means it's going to break down to 5 triangles. Equivalent triangles. Awesome. So what I'm going to do is I'm going to find the area of that shaded area. So I'm going to go ahead and do my formula, which you guys all should know. I said there are 2 formulas this chapter you really need to know. And trapezoids, you should, but you don't really have to. Except for you do need to know where the formula derives from. Like, remember that whole thing with why you take half the height and why you add the bases. Remember that? Hello?
Yes.
Okay, good. Okay, so I'm going to go ahead and find the area of that one triangle. Do I have enough information to do that?
Yeah.
Yeah. So I'm going to go ahead and do times 12. When you do that, you're going to get 105 centimeters squared. 105 centimeters squared. Quit talking. 105 centimeters squared. But remember, that is only representing what I have highlighted in blue. Okay? So what do I got to do now? Well, if that means that all of these are 105. That's 105. That's 105 square feet. That's 105 square feet. That's 105 square feet, and that's 105 square feet. Or, sorry, square centimeters. So I've got to either add them all up, or just do 105 times what? 5. And you're going to end up getting, what, 525?
Yep.
525 centimeters squared. How many points do you think this is going to be worth? 3. Formula, answer, units. Same thing. Formula, answer, units. Everybody got that? Okay. I would like everybody to try this one right here, please. Alright, so let's check out the results here. Okay, so we had 3 different answers. Now, this is pretty good. This is always what makes me happy when we have mistakes that are, I know where you made your mistake. That's good. The correct answer is the largest bar there, 370.8. Now we had 3 people that had 309. I'll show you exactly what your mistake is there. That is a silly mistake. You'll see what I mean here in a minute. And then 61.8, you'll see exactly what that mistake is. And it's not a huge deal. Just understand that you've got to get this figured out. On the video last night, I said there was one major mistake that I see year after year. And I'll show you what that mistake is now. Everybody that did it, here's the good news. Everybody that just got an answer, whether you got it wrong or right, you started right. You found the area of one triangle. you did your formula. Area equals 1/2 base times height, right? Then you did 1/2 times 12 times 10.3, because that's your base and height. And you got 61.8 inches squared. Okay? Every single one of you got that right there. So realistically, that's the hardest part of the whole thing. This is where it started to, this is where the people made the mistake, I guess. So you did 2/3 of the problem correctly. Okay? The one person that had 61.8, I think it was one, yeah, one person. What did that person forget to do? What did that person forget? Ricky?
You forgot to multiply like all the other.
Yeah, remember, that is just one of those. One of those is 61 and 8/10 square inches. You've now got to take it and say, each one of these is 61.8. Now you don't have to go through here and write 61.8 on every one, but sometimes it kind of helps you to remind you that each one is 61.8. Now, if you were somebody that had 309, what you did is you multiplied by 5. And why did you multiply by 5? Because the last question was a pentagon. Silly mistake. Make sure, and by the way, I guarantee if these were switched, if we would have done the hexagon first and the pentagon second, I guarantee people would have been multiplying the pentagon by 6. It's just because you just got in the habit, you saw me do it here, multiply by 5, and you did it that way. But just be careful. Make sure you count it. Remember, however many sides it has, that's how many triangles that can be created from it. Is everybody feeling pretty good here?
Yeah.
So it ends up being 370.8 inches squared, I think, right? Did I get my 3 points here, guys?
Yeah.
I got a formula, I have an answer, and I have inches squared. Okay, we're going to skip that next question. Okay, let's go ahead and look at this one, right? No longer. Cheaters.
Oh, yeah.
All right, here we go. I would like everybody right now to please go ahead and do that one. So the area of this, obviously, what we're finding, obviously this is not great, right? And that's okay. I mean, in my other classes, I went ahead and just went over that one and then started. But I like to just start with this one because I think sometimes you guys gotta not do as well. Okay, because when you don't do as well, it kind of forces you to really lock in and say, what did I do wrong? And then hopefully you'll learn from your mistakes. So the correct answer was 23. So like third period, I mean, we were a little better. We had 52% of you get it right. But still, half of you getting it right really isn't good enough. So let me try to give you some strategies here. Well, actually, I don't want to do it that way. I want you to give me the strategies you did. Somebody explain the strategies that you tried to do on this question right here. Go ahead, Erin.
So first, what I did is right where there's an inward angle
Yep.
on the right
Where?
side, I made a line across.
Left or right?
Like left to right.
Okay. Okay, so you did that.
And then I saw that on the right side it said 3 inches, so I knew that the bottom would be 2 since 5 minus 3 is 2.
Beautiful.
Like the bottom height.
So basically what she's saying that she knows that from right here to all the way up here, she knows that that is 5 inches. Does everybody agree with that?
Yes.
Well, if you cut it like that, that means that right here to right here has to be congruent to that over there, right? 3 inches. So she knows that's 3 inches. So if, do you guys remember this? Whole minus part equals part. If I know the whole distance and I know part of it is 3 right here, then can I figure out the other part by subtracting? 5 minus 3 is going to tell me, okay, that's 2, and that's fine. Okay, keep going.
And then I saw that there was a line on the one side that didn't have anything on it, so I just stopped for a minute, and then I saw what shape it was, and I saw that the top was 4 inches,
Sure.
and that same line is the same length.
She knew that this right here had to be the same length as that, right? Right? Okay. Now I'm going to do this a little different because I can tell that you decompose this into a rectangle and a trapezoid, right? That's fine. Is that how you did it? Okay, now that's fine. But we like to decompose into triangles and rectangles because as I told my other classes, I bet you out of the 22 of you that are in here, I bet you maybe 5 of you will remember that trapezoid come next year. Maybe 5. Now some of you might be, okay, I know it's something about adding the bases. Like you'll remember some parts of it, but you won't remember it. But you will remember the triangle formula and you will remember the rectangle formula. I guarantee it, I promise you will. Everybody does. So my thing is, let's try to decompose this into triangles and rectangles only. So if I were to do that, couldn't I just cut this thing straight down here like that? Okay, so first of all, I'm gonna just put an X, a green X, through the shape if I have enough information to be able to find the area. That top one right there that's got yellow and red around the edges of it, do I have enough information to find the area of that? So I'm just going to kind of just do this, just to help me remind me. Okay? Do I have enough information right now as it sits to find the area of that rectangle?
Yes.
Just by looking at it right now? What is it?
2 and 4. No, it's
He's absolutely correct. Yes.
What?
That's it. Look.
Oh, yeah.
Remember, you know what? This gives me an opportunity to go back and talk about one thing real quick. Are those two things you see right there, are they both parallelograms? Now, isn't this one a special type of parallelogram?
Yeah.
What makes it special? Aiden? It has all right angles. But we've got to know the definition of a parallelogram. Parallelograms say that opposite sides are what? And congruent, which means equal. So they are parallel. Okay, that's obviously a big part of it. But the biggest thing is they're the same length. So if this is 5 centimeters, then this is 5 centimeters. So going in the same for rectangle, obviously. So coming back to here, he knew that right there in yellow, that was 4 meters or 4 inches. I don't know why I got looks like an M. Okay, so if that is, aren't all those in yellow going horizontal right there? Aren't those the same length? So I'm going to get my green out here, and I'm going to put another X because I can do the area of that. I know a base and a height. Now we're on to the triangle. Do I know a base and a height off that just looking at it? No, so I got to do some work here. So I'll pick a different color, and I need to figure out what that length is, and I need to figure out what that length is. This is where you really got to be able to think kind of deeper. How am I going to figure this out? Yep.
If the entire bottom is 7, and then the rectangle part at the top is 4, subtract 7 by 4.
You got it. Again, whole minus part equals part. If I know it's 7 inches from right here to right here, from right there to right there, and if I know that it is 4 inches from there to there, how many inches do I have left here, guys? 3 inches. Okay, now we got to figure out the height of this triangle. Okay, what's the height going to be? Go ahead, Jace. Yeah, because again, I know that isn't this height from here to here 5? From right here to right here, guys? So isn't this also going to be 5? Or even if I went from right there straight up, isn't that still 5? Hello?
Yes.
Absolutely. So if I know that from right here to about right there, that's 3, right? According to this, right? So how many more inches do I have? 2. It's really hard to see. It gets to be kind of a mess, doesn't it?
Yes.
But that's kind of the way you got to take care of it. Now, can I go ahead and get my green X and put an X through this? Yes, I can. I know my base and my height. So, here we go. This one here. The area equals base times height. That's going to be 4 times 3. That's 12 inches squared, right? Right, guys?
Yes.
This one is going to be 4 by 2. Isn't that going to be 8 inches squared? And this triangle is going to be 1/2 times base times height, which is going to make it 3 inches squared. What's 12 plus 8?
20.
Plus 3?
23.
23 inches squared. Now that's all well and good, guys, but you made it a whole lot harder than it has to be. Okay? The best way to do this is just to simply come straight down here, because you basically did that anyway. Didn't we end up doing that? Then you know, okay, I look at it and say, okay, that's 5 by 4, and then I know that this is 5, so that's still 20 inches squared there. And then same reasoning Luke just gave us on this one. If it's 7 from there to there, or I'm sorry, yeah, 7 from there to there, and from right here to right here I know is 4 because of that, then that's got to be 3, that's got to be 2. We still get 3 inches squared there. So 20 plus 3 is 23 inches squared. How'd you do it? So I think what she's saying is she's doing something like this, right? Is that what you did?
Well, like I did like 5 and 7 to get 45, and then
5 and 7 is 35.
well, yeah,
Okay.
and then 4 times 3, 12, like
5. So you did this times this, and that should be the area of this whole thing, right?
9.
I mean, it would be. The whole thing's 35. That makes sense. Okay. And then you did 4 times 3. I don't know if you can rely on that.
Like I didn't really like know what to do. So
Well, I don't want you to rely on that because I'm not sure why that worked. Because I don't know why you would. If you did that, some people do it like this. Some teachers teach it like this, and I don't really like it this way. But they'll find the area. They'll get 35, and then they'll find the area of that part right there. But that's kind of. I mean, it's basically the same way, just backwards. It's the opposite. So let's go on. Let's try the next one. Let's see if we can be better on this one now. Go. Okay, so we got a lot of different answers for this question. We have 0, we have 35, 205, 211, 218, 225 was the correct answer. Then we had 585. That's a lot of different answers for something that now we've done. Is this the third one we've done? Second one. Okay, so we still got some time to practice, but we got to start getting this. So make sure you're taking little notes, writing this down. Okay. So again, there's a couple different ways you can cut it. Obviously, as I'm walking around, I saw a lot of you just simply cutting it straight across like this, which is fine. But then I saw others kind of cutting it like this. Let me give you another strategy that you guys can do. Okay, maybe this will help you. I want everybody to write this down. This could be a good thing. Okay? Sometimes when it's in that form, when it's in that composite figure form, it's kind of hard to see things. What I'm going to do is I just basically redrew that little rectangle. You guys see that? So I'd like you guys to do that as well. Okay, and then I redrew the big rectangle, and I'm going to put that right there. Okay, so, and then we're going to label them too, just so we can keep everything straight. This is A. Whoops. That's A. Just said that. This is B. This is B. Is everybody cool on that? Now, I'm just doing this one over here for now, so pay no mind to the way we cut the other one. We'll just cut it this way for now. Okay, guys. Now, when I look at this, when I see it, when they're separate like this, I just think it's easier to see. Because I think you guys would all agree you need to know a base and a height and a base and a height. I don't know why when it's in this form we struggle so much, but it's just, it's all about just getting you guys to see it. And sometimes, you know, I've told you guys before, like when I took geometry in high school, and I'm a math teacher, I got C's all in every geometry, every quarter in geometry. That's saying a lot for somebody that my best subject was math. And it was because in geometry, I don't know what it was, but I just couldn't, I really struggled with being able to think that way. And I hear you guys say that stuff all the time. Oh, I'm terrible at geometry. Oh, I'm amazing at geometry. You know, you guys always say those things, and there's something to it. Now that I'm older, I've gotten a lot better at it, and it's like I just wasn't mature enough to do it. I have no idea. And that's where some of you guys are now too. But really be listening and really be trying to understand where I'm coming from here, because I think it's going to make sense, especially doing it this way. So when I'm looking at this right here, you guys would all agree. What I have in blue there, are they the same distance?
Yes.
What I have in green, are those the same distance?
Yes.
Well, I'm going to color code this whole thing, and I know you guys probably don't have colors. That's okay for now. Bring them tomorrow, though. Bring them for the test, so that you can bring them tomorrow and for the test. There's something that can help you. Okay, then I'm going to do B. Okay, would you agree that those two distances are the same? Hello?
Yeah.
Remember, that's just the definition of a parallelogram. Okay, and then finally, we'll put the yellow on there. We'll put these. Would you agree that what's in yellow are the same length? Now what I'm going to start doing is I'm just going to start putting on what I know. Because what I've done is I've color-coded it in a way that will allow me, I've color-coded it in a way that is going to allow me to be able to tell the same color is the same length. So do I know what color that, or what the length is there?
No.
This right here?
No.
Oh, yeah, that's hard.
That's supposed to be blue. It's purple looking, but so that's 13 inches. So would you agree that this is also 13 inches? Here, let me do something real quick.
Whoa, whoa. You messed it up. You done messed up.
Great. Okay. So anyway, that's 13 inches. I made it too close. That's all right though. So I know those are 13. Okay. Now, what I have in yellow. Wouldn't you agree that that's that right there? What is going on here? Oh my gosh. Wasn't it right there? There we go. Got it back. Okay. All right. So what I have in yellow right there. Oh. Kidding me. All right. I think I can get this. There we go. We did it. Okay. What I have in yellow, is that also 13, guys? Hello? So right now, do I have enough information to find the area of this square right there? Okay, so I'm going to go ahead and put a green X through it just to remind myself I'm good. I got that down. I don't expect you guys to do that because you can write your area in the inside, but I'm just trying to get you guys thinking that way. Now let's get on to the smaller rectangle. Okay? Now, do I know the length of the blue? So that's this right here. Do I know that length? Hello? No, I do not. But, again, where am I? Come on back. Okay, now, right here, I know that the distance from right here all the way over is 13 inches. Does everybody agree with that? Okay, now, I need to know the distance from right here to right here. That's what I'm trying to figure out, which is going to be the same distance as from the dotted line there. Do I know the distance from right here to right there, though?
Yes.
Don't I know that that's 13, guys? Right? Okay, so if I know that this whole distance right here is 13, I need to know a part. I need to know part of this. Do I happen to know that right there? Yes, I do. I know that that is what? 5 inches. So if it's 5 inches from right there to right there, how long is it from there to there? Well, whole minus part would tell me that this is 8 inches. This is 8 inches. Now, do I know what's in green, guys? 7 inches, right? Because of that right there? 7 inches. Can I find the area of this now? Do I have enough information? Yes, I do. So here we go. I'm ready to find the area of both. So I do area equals base times height. That's going to be 56 inches squared. And this one's going to be 13 times 13, which is going to be 169 inches squared. I need to take them and add them up, and that's where we got our answer of 225 inches squared. Okay? Did that help? Raise your hand if you feel like making them into 2 separate rectangles is kind of a method that you can take advantage of. Okay? If not, don't do it. I don't care. I'm just trying to give you strategy. Who agrees that maybe the colors will help to kind of help you out? That's fine too. That's fine too. Okay, use them. Okay? Now I want to real quick just show you the other method real fast here. The one that was here, cutting it straight down like this. Obviously my shapes would be different, so I wouldn't be able to use these anymore, right? I'd have to use different ones. But I'm not going to go through this one. If you would have done this one, you would have realized, okay, if that's where I cut it right there, well, if that's 5 inches, isn't that also 5 inches right there? So I know that one. I got enough information there. But then, can I figure out this?
Yeah.
Sure, by doing 13 minus 5, right? So then I know that's 8 inches. But then I've got to know the height of this thing. Do I know it right off the top of my head? Is it given?
Yeah.
No. You've got to do some work. That height is going to be the same distance as from there to there. Okay? When I look at this, do I know the distance from the very bottom to about right there? What's that distance? Isn't that 13 right there? So then what's the distance from right here to right here then? 7. So we got to put them together. That's going to be 20. So now I could do it this way and say, okay, my base and my height is 8 and 20. That's going to give me 160 inches squared. And then 5 times 13 is 65 inches squared. You still get 225 inches squared. Okay? Let's go ahead and try the next one. Okay, first thing I'm going to do is I'm going to look up see the results here. Okay, now we're doing much better. Now it's a relatively easy question as far, not easy maybe it's not. I'm not saying you should, like the people that missed it should be embarrassed. I'm saying compared to the other ones, it's easier than the ones we've done so far. This one is. Okay, now I see 37 is the correct answer. We had 29, 38, 51. We had 2 people get. Then we had a big number there, 168. So those people need to be paying attention big time. Now you can cut this a couple different ways. The first way I think that people should cut it would be like that. I always see people do that. And the people that got 51, I can show you what you did. You did your 3 by 7, and that's 21 centimeters squared. And then they did 15 and 2, and got 30. So you 2 people that had 51, let me see who you are. 1. You 2 people that did that, understand that the distance, guys, please listen, from right there to right there isn't 15 centimeters. It's the whole distance of the figure's 15. So you'd have to do some work to be able to say, okay, if it's 15 from right there to right there, and I know that it's 7 from right there to right there, then I know this has got to be 8 and this has got to be 8. So that would be 16 centimeters squared and 21 centimeters squared. That's where 37 came from. But the other ones that cut it the other way, you cut it like horizontally, right? And then you can do 15 by 2, and you got 30 centimeters squared. And then here you'd have to do some work. You know that it's 2 centimeters right there, so how far is this got to be? 1 centimeter. And I know that's what I was talking about, how it's drawn kind of weird. So that's going to be 30 plus 7 is 37. But again, guys, if you did it like this, it only takes a second to quickly go over to the side and just try to draw something close. It doesn't have to be perfect. Just there it is. And then you just put on what you know. Okay, well I know that this is 15 centimeters by 2 centimeters, and I know this is 7 centimeters by, I got to figure that out. Well, if the whole thing's 3, and this much of it is 2, then I have 1 to go, and there I get it that way. Go over and try the next one to the right of it. Okay, so the correct answer was 54, which most of you got. We still have one person getting 12. I'm not sure where 12 would have come from. I think I know where 84 came from. I think. Regardless, okay, when you take this, and the first way to do this, I think the way that most people do is they cut it there. The problem is I think you guys are thinking that this right here is 3. But that's not 3. Okay, well actually it is 3, but it's not. It isn't this 3. Okay, makes sense. Okay. Now I know the distance from right here to right here is 9 feet, right, everybody?
Yeah.
So, and if I know it from there to there it's 6, then I know this has to be 3 feet. So, guys, quit it, please. Quit. This right here is 12 square feet. Okay. Then I know that it's 6 by whatever this is. So I need to know what this is. Well, again, this is where you got to use your strategies and say, well, it's the same distance as from there to there. If I know it's 4 feet to there, and it's 3 feet. If I know it's 4 feet to there, and I know it's 3 more feet to get to the edge, then I know, doesn't this have to be 7 feet up here, guys? So I know it's not 9 by 7. You guys are getting 9 by 7. You're getting 63 and then adding 12, I think. Or somewhere in there. Okay? It's 9 by 6. This is why it's going to help you to redraw it. Okay, I got 6 feet there. This is 7 feet. And then redraw the little rectangle. This is 4 feet by 3 feet. And that'll help you. Okay? And then the final area ends up being 54 square feet. Alright?